Hi, this is Javier Encinas. This is an overview of ASDIP Steel, our software for design of structural steel members. Let's open ASDIP Steel. This is the project manager. From here you can create a calculation, specify your settings, units, information, and save or open in your files. In this version, 3 modules are included. One module is for base plate and anchorage, which includes anchor rods or shear lugs design. And the second module is steel column. And the third module is either steel or a composite steel beam. Let's start with base plate and anchorage design. Let's add a name, any name. So the calculation is now added to the tree. Double click. This is the calculation sheet for the base plate design and anchorage design. The typical calculation window is composed of a menu bar at the top, and immediately below is the toolbar. From here you can have access to any the most important commands in the program. This is the working area. It's composed of 2 panes, 2 tab panes. The left tab pane is dedicated, designed for the input data. The right pane is for calculation results. The user interface is very efficient, has been designed to model your structure the easiest way. It consists of different types of controls like buttons, text boxes, labels, radio buttons, etc. All these combined elements create a rich user interface. The input tabs are organized in a logical way to avoid confusion where to specify a parameter. For example, in the geometry tab, you can specify all the dimensions of the base plate and the supporting concrete support. Also, you can specify the column. If you click on the ASDIP sections, that shows our built-in sections database of the ASI with the section that apply to this module. From here you can select the module or the column, the section that you are interested in, and so on. Also the base plate dimensions, the column dimensions, if not selected from here. The rod offset. You know, in this image, you can see the meaning of all the variables in this page: the rod offset and the column length, the width, and so on. In the next tab is the loads. This program can do the calculations in ASD, service loads, or LRFD, factory loads. Includes vertical load and moment about the strong axis and horizontal shear. The material tab includes the material properties for the support, for the plate, and for the anchor rods. Here is the concrete and reinforcing steel. In the plate is the FY for the steel, and here is the type of analysis you are interested in. If the strength compatibility is enforced, is according to one reference, and if it's ignored, it's according to another reference, the AISC. The anchor rods, you specify the number of anchor rods, either 4, 6, 8. The diameter and the material type of the anchor rod. In the anchorage design, it has 2 more tabs. One is for the tension analysis and another is for the shear analysis. In the tension analysis, all the ACI Appendix D in the 08 and 11 edition of the ACI 318, it's included in for this tension analysis. And in the shear analysis tab, again, all the Appendix D in ACI 11, it's included in this tab. Here you can select if the shear is taken by friction, by shear lock and friction together, or by anchor rods only. If you are designing a shear lock, then, for example, if we select here, all these fields are available for the shear log design. In the right pane, the calculation results at a glance shows in one screen all the most important results, and you can see at a glance if it fails or passes. For example, in this case, it's failing in shear. The ratio is 2.74, so it's failing in shear. So we need to take care of that in the design. If you need more information, you go to the next tab, the condense, and the results are shown here with more detail. From here you can see the base plate design, different theories, and the anchorage design as well, in tension and in shear. And we know that in shear is failing. This is not good. It's failing. And the summary of results. Okay. If you need even more information than this, more detail, go to the next tab, detail, and the results are presented here with all the formulas exposed step by step with reference to the ACI code or the AISE code. That depends if it's the steel or the concrete. In the anchorage design, this is Appendix D. Okay. And all the results, the shear analysis and with all the typical failure modes are shown and are calculated here. So you can follow the calculation step by step. If for some reason you need to check one specific calculation in a particular failure mode, you can check it here. Everything is exposed, nothing is hidden. So it's a very nice way to present the calculations in a software. In the graph tab, it's presented graphically the result, the base plate with the column, and we show the bearing pressure in the compression triangle that is generated, the thickness of the plate, the resultant, and the tension in the anchor rod. In the tension breakout, this is a very important very important calculation, because it shows graphically ANC, which is the area of the breakout. Difficult to calculate, particularly if it's in a corner or in a narrow area. It's a little complicated. The program does it internally very, very well. And the shear breakout, same thing. If the front rods are taking the shear, or if the four rods, that depends. If for example here, if the rods are welded, then the back rods are effective. If the plate is not welded to the anchor rods, only the front rods are welded. So this is the first module in the package. Let's see very quickly the detailed report, which is predefined and pre-formatted. Page 1, page 2, page 3, 4, 5. You can see everything together here, and you can print out and show it to your checker, to your client. This is the first module. Let's go very quickly with the steel column. Let's assign a name, any name. The name is added to the tree as did before. Double click. This is the calculation sheet for the steel column. In the geometry, you can specify also the geometry here as we did before with the properties, column length, embrace length, and the effective length. These are some typical values. In the loads, works in ASD or in LRFD, service or factor, the required strength. If the column, if the loads are from the second order analysis, no further magnification is necessary. But if it's the first order analysis, probably a magnification is required. So you go to the parameters, and you can specify here the fields, and the program internally calculate and amplify those that you apply to the program. In the right pane, again, at a glance, it's just one screen with all the calculations. Everything passes in this example, perfect. If you need more information, go to condensed, and you show, it's shown, with the limit states. It's more involved a little bit. compression and bending in X, bending and Y, combine. So it's more involved. If you need more information, go to the detail report, the detail tab, and the calculations are shown here with exposed formulas and a reference to the code as we did before. So you can check, all the formulas and everything step by step if necessary. Graphically, it shows the interaction diagrams of the column. So it's a very nice way to present the adequacy of the design. Let's go to the third module in the package, which is steel and composite beams. Double click. This is the steel and composite beam calculation sheet. Same philosophy. In the geometry, you specify the steel beam that you're gonna analyze. You select the type of beam that you want from the tabs here, and then select the section that you are interested in, and so on. The Fy and modulus of elasticity, properties of the steel, if it's a composite beam or not. If it's a composite beam, this tab shows up here. Here you specify the lateral bracing of the beam. For example, this little yellow circle represents the lateral bracing. It's 10 feet from the support. It's lateral bracing and so on. So you can specify here the length, the span, and that also includes two cantilevers, left and right if necessary. In the composite section, you specify here the slab and deck properties if necessary, thicknesses and dimensions properties, and the shear studs if it's a composite design. Also, you can specify, so this is a very nice feature in the program, if you want a partial composite, you specify here the partial composite, or if you let ASDIP calculate, it finds the minimum number of studs required for the design. In the loads, ASD or LRFD as previous, uniform loads, two of them, or concentrated loads, six of them as possible. At a glance, you can see in one screen if something fails or if everything passes. In this case, everything passes. If you need more information, go to the condense as before, and all the information is here. The limit states for flexure, the limit states for composite, the shear connection design, and the deflection. Everything is in here. If you need more information, go to the detail. And again, all the calculations are exposed with the formulas and references to the code. Design for shear, design for flexure, not composite, design for composite, and finally deflection. So everything is there. Graphically, you can see the diagrams and the shear diagram and the moment diagram for different loads, and the reports show. Let's see the detailed report. It's loading there. Page 1, page 2, page 3, page 4. If you want to see everything together, looks like that. You can print out this and show it to your client. Okay, these are the three modules that compose ASDIP Steel. Thank you very much for your attention, and we'll see you in the next video.